Today I'll show you the steps of making a biodiesel and how can you make it at home. Biodiesels are used in specifically diesel engines whose fuel ignition takes place without any spark. Therefore, diesel fuel needs good compression ignition characteristics. Vegetable oil is significantly more viscous and therefore has more poor combustion properties comparing to the other two examples here. Thus, it can cause many engine problems. The reaction we are going to talk about today actually shares many similarities with Boss method to actually change the viscosity of comogra oil by breaking down its structure and make it more water soluble and therefore safe to inject as a drug treatment. We can see that this structure is really bulky and therefore we can imagine it really hard to um, uh, be soluble in water. What she did was two parts. The first part is breaking down this structure of the oil into these three parts actually. So two of the smaller chain of this acid and then one of this acid. You can see that it has two of this and one of this. As we can see, the first reaction broken down this bulky structure into smaller parts. The alcohol plus ester make it to different alcohol and ester, which is also called esterification. And that we need three reactions to break down this triglycerol. So that we can break down every branch of this ester and therefore release them. However, after this first reaction, the good news is that we have two acids that are the active agents for the disease, but the bad thing is that they are still unsuitable for injection because they foam up like soap because free fatty acids react with alkali ion to form soap if you're using base catalyst. And if they form, the soap which will make them unsafe to the body's blood cells. So what she did for the second reaction was to change these carboxylic acids into their ethyl esters, which solves this problem. This R1 refers to this giant part, and this R2 refers to this part. Therefore, this whole thing, turning this into this, is called Ball method. The drug in the end had tremendous success in Hawaii and treating the We can see that for biodiesel production, these steps are really similar to Alice Ball's method. So we are turning this vegetable oil into methyl esters. In fact, in nature, fats are general triesters, which are derived from this glycerol, glycerol and these fatty acids. And this biodiesel also are called fatty acid methyl ester, which are shortened for as FAME. There are two ways of doing it. The first I would like to introduce is base as catalyst. In the reaction, we will mix the alcohol and the base first. Uh, um, this is a catalyst, so how it works is that the alcohol will actually take the uh, elect electron from the base, and the base will give an electron to the alcohol. So we know that from this reaction, we can recall that this alcohol acts as Lewis acid because it accepts the electrons, and it's also electrophiles. The base is also nucleophiles. We can see that after the reaction with the catalyst, it became another ester, and that this this RO will give an electron to this carbon, which is in this triester. And then, so this RO will come to this carbon, and because we also will see this oxygen taking an electron. And then next step, the oxygen will give its electron back to the carbon, and then this electron given to this oxygen to let this part out of the triester. And after that, we can take this acid and then neutralize this base, and therefore it became it finished the first reaction of these transesterification. So we can see that the base here did not change in any form, so it's a catalyst. This is the reaction mechanism for the base as a catalyst. We have to note that the mechanism are a proposal of how this reaction worked and not always right. It's interesting to know that byproduct does exist, therefore it has a high production cost. To separate those formed soap product. Next, we'll look at the acid as a catalyst. In this acid catalyst, we can see that the proton from the acid will actually form a bond to this oxygen, and then make this carbon having a plus sign. Therefore, it can react with this alcohol, and through a series of moving its electrons, finally this bond breaks, and it forms a this ester plus the proton. This proton is from breaking this bond, and then this H is from this side, and this COO is from this COO. Transesterification is means an organic reaction in which the R group of alcohol is exchanged with the other another group from an ester, a functional group. If you want to DIY it at home, you can try with vegetable oil. First, you can actually measure them first to do this experiment. So first of all, you can heat up. So generally, first of all, you heat up the vegetable oil, and then you use another place to mix the alcohol and the catalyst together, and then you mix them up, and then you neutralize the acid with the base with acid, and then let it sit for a few hours, and then you can separate them. So the top layer will be the biodiesel, and the bottom layer will be the water, salt, and glycerol. In a more industrialized scale, there are three general steps. First is feedstock pretreatment. Second is so the first is basically pre-treat your reactants, and the second is to do the reaction, and third is product purification. As we can see, this is what I just described from the oil mixing with the alcohol and the catalyst. And then this is the mixed methyl esters, like it will start forming layers. And these steps is generally to reuse the stuff that you used, for example, alcohol, and this is also the byproduct glycerol. And this is the place where the biodiesel came out. You are gonna wash it several times with water and then separate them several times to make good and pure product, as pure as you need it. In market, blending biodiesel are more common, and they have couple names. So if it's a B2 biodiesel, then it has 2% of biodiesel and 98% of petroleum-based diesel. And if you have B50%, then that means you have 50% biodiesel. And you have a B100%, 100, that means 100% of biodiesel.